Hello friends, welcome to Physics Live channel. Today we are discussing about complex analysis part 5 class. So we already studied about to find the function from u of x comma y from the equation integral f1 minus if2. So here v of x comma y is given and we have to find the function f of z. Okay, so what is the procedure? So we have to find dou v by dou x, and that is f of x comma y, a function of x comma y, and put x equal to z. Similarly with the previous concept, that is similar to that, x equal to z, y is equal to 0, and f1 of z comma 0 is the dou v by dou y, that is also a function of x comma y, and put x equal to z and y is equal to 0, so f2 of z comma 0. So f of z is equal to integral f2 plus if1 dz. So this is the formula when v of x comma y is given and we have to find the function f of z, that is equal to integral f2 plus if1 dz. Integral f2 plus if1 dz. So the problem v of x comma y is equal to y plus 3x square y minus y cube. So find f of z. So dou v by dou x, that's equal to 3 into 2xy, only x is there, so 6xy. Put x equal to z, y is equal to 0, so this is 0. So f1 is equal to 0. Dou v by dou y is there. So 1 plus 3x square minus 3y square. X equal to z, y is equal to 0. And that is 1 plus 3z square. So this is f2. Formula is integral f2 plus if1. So integral 1 plus 3z square dz. So z plus 3z cube by 3. So z plus z cube. This is the function. Z plus z cube is the function. So we have to remember the formula, that is f2 plus if2. f2 plus if1. Sorry, integral f2 plus if1. Next, v of x comma y is given, that is tan inverse y by x. So we have to find dou v by dou x. We know the tan inverse y by x formula with derivative, that is 1 divided by 1 plus x square. So here in terms of x, y by x whole square, and derivative y by x with respect to x, 1 by x derivative, that is minus 1 by x square. Okay, so we get that minus y by x square divided by x square plus y square divided by x square. So we get the minus y divided by x square plus y square, and put y is equal to 0. We get f1 is equal to 0. Okay, so next dou v by dou y, that's equal to 1 divided by 1 plus y by x whole square. Derivative of y by x with respect to y, that is 1 by x. So 1 by x divided by x square plus y square divided by x square. So x divided by x square plus y square. Put x equal to z, y is equal to 0. So we get z divided by z square, that is 1 by z. So this is f2. So the function f of z is equal to f2 plus if1. So that is integral 1 by z dz. So 1 by z integral 1 by z log z. So this is the function. Okay. So when v of x comma y is given, function is given by integral f2 plus if1. f2 plus if1. Next problem in which v of x comma y is given as x minus y divided by x square plus y square. So we have to find dou v by dou x. Dou v by dou x, that is, we know that it is a division. So denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator square. So we substituted there y is equal to 0. So z square minus 2 z square divided by z power 4. So minus z square divided by z power 4. So that is minus 1 by z square. This is f1. So dou v by dou y. So that is denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator square. So put y is equal to 0 and x equal to z, that is minus z square minus 0 z and divided by minus z power 4. So that is minus 1 by z square. So this is f2. So we know that the function f is equal to f2 plus I f1 dz. So that is integral f2 is minus 1 by z square plus I into f1 as minus 1 by z square only dz. So minus 1 by z square, z square, that is z raised to minus 2 only. So my z power n plus 1 divided by n plus 1. So that is minus 1 by z only. So minus 1 by z. So from that we get 1 by z here and plus I into minus is already there, 1 by z square, the integral, that is minus 1 by z, so 1 by z. So 1 by z plus I by z. This is the function get from this v of x comma y. Okay, so next problem, that is v is equal to minus sin x sin hy is given. So we have to find dou v by dou x, that's equal to minus cos x sin hy. Put y is equal to 0, so we get a function f1 is equal to 0 and dou v by dou y, that is minus sin x cos hy. So cos hy is equal to 0 and put x equal to z, that is minus sin z for f2. So the function f is equal to integral f2 plus I f1. So integral minus sin z. Sin z integral of sin z minus cos z. So minus of minus plus cos z. So the function is plus cos z. Next problem, that is v is equal to log x square plus y square plus x plus y is given. So we have to find dou v by dou x. So for that 1 divided by x square plus y square into 2x plus 1. So put x equal to z and y is equal to 0, that is 2z divided by z square plus 1, that is 2 by z plus 1. This is f1. f2, that is dou v by dou y, that is 1 by x square plus y square into 2y plus 1. So that is 2y, y is equal to 0 only, so 0 by something is equal to 0 only, so f2 is equal to 1. So the function f is equal to integral f2 plus I f1. So 1 plus 2 by z plus 1 I into 2 plus 2 by z plus 1 dz. So that is z plus I into 2 log z plus z. So this is the function we got from this v of x comma y. So here we have to remember two equations. That is, when it is given with the u of x comma y, to find function, that is f1 minus I f2. and if it is v of x comma y is given, and we have to find a function that is f2 plus if1. So you should remember these things, and you have to know what is f1 and f2 and what is the conditions, but this like put x equal to z and y is equal to 0, like that you have to remember. Okay, next we have to know about singularities. Next topic is singularity. So what do you mean by singularities? Okay, so singularity is the singular point is a point at which the function is undefined. The function undefined, that is at the point. So function is undefined at the points. So that point is known as a singular points. So if you are considering 1 by z minus a, that is 1 divided by z minus a, at z is equal to a, the function is 1 by 0, that is function is undefined. So function f of z is equal to infinity at z is equal to a. So 0 by 0, 1 by 0, 1 by infinity, these types of values at which the values, the points are known as a singular point. So how to find the singular point? To find singular points, we have to put that this denominator equate with the 0, and we get the points. Okay, so if you consider function f of z is equal to z divided by z plus 1, z minus 2. So to find the singular points, we equating denominator with the 0. So that is z plus 1, z minus 2 is equal to 0. So z plus 1 is equal to 0, z minus 2 equal to 0, z is equal to minus 1, z is equal to 2. So these are two singular points. So if you consider 1 divided by z power 4 minus 1, this is function f of z. So z power 4 minus 1 is equating with the 0 to get the different singular points. So z power 4 is equal to 1. So we know that for this function we have 4 roots, that is plus or minus 1 and plus or minus I. So these are the singular points. Okay, so this is the way to find the singular points. If we are considering the function z divided by z plus 1, z minus 2, the function we get z is equal to minus 1 and z is equal to 2 are the singular points. Okay, this type of singular points is known as isolated. That is isolated singular points means a very few singular points are there. Up to 4 singular points we are considered as isolated singular points. If you are considering the function z divided by e raised to z minus 1, and we know that denominator is equal to 0, so e raised to z is equal to 1. So e raised to I to n pi can get the values of 1. So we got numerous values for this. N can be infinity, up to infinity we get the points. So this is non-isolated. So many points are there. So this is non-isolated singular points. Okay, so many points are there, so it is known as a non-isolated singular points. Okay, so this is the type of singularities, and if you consider the function f of z is equal to summation over positive powers and plus negative powers are there. That is, if you are considering a function which contains the analytical part and principal part, that is summation over n a n z minus a all power n plus summation over n b n z minus a all power minus n, that is z in terms of numerator and z in denominator. These type of part is known as principal part. This is known as analytic part. Okay, so if you are considering a function e raised to 1 by z, so e raised to x, you know that 1 plus x plus x square, 1 by 2 factorial, like that, x square by 2 factorial plus x cube by 3 factorial, like that. So here 1 plus 1 by z plus 1 by 2 factorial 1 by z square plus 1 by 3 factorial 1 by z cube plus etc. So here we know that this is analytical part. So here the numerous terms which have principal part means z in denominator. So this is principal part. So principal part contains infinite number of points. This is known as essential singularity. So essential singularity is the principal part contains infinite number of terms, that is known as essential singularity. Okay. So if you are considering a function f of z is equal to cos 1 by z. So we know that how to find this singular point. To find them, denominator equate with 0. So set cos theta is equal to 1 minus theta square divided by 2 factorial, like that. So 1 minus 1 by z square 1 by 2 factorial is the plus 1 by 4 factorial 1 by z power 4 minus, like that. So we have infinite number of terms are there. So if you put multiply it with these terms, so z divided by 1 by 2 factorial 1 by z plus 1 by 4 factorial 1 by z cube, like that. So you get principal part which have infinite number of terms. So it is essential singularity. So from these two examples you got an idea about essential singularity. Essential singularity in which we know that the principal part contains infinite number of terms. The principal part means what is that? Principal part that is said in the denominator. Okay. So, and what is pole of order? Pole of order. These are the new terms we have to remember. Okay. So, pole of order. Pole of order, if you are considering a function z divided by z minus 1 whole square, z minus 2. So we know that singular point, to find singular point you are equating with the denominator with equates the 0. So you get z is equal to 1 and z is equal to 2. So this is order 2 singular point. Pole of order 2. This is order 1. So pole of order 1 and pole of order 2. So this is pole of order. So this is order 1, this is order 2. Okay. So what do you mean by another term, that is removable singularity? Removable singularity. So what removable singularity means, we know that if you are considering a function sin z divided by z, the function, you know that sin theta is equal to theta minus theta cube by 3 factorial, like that. So here 1 by z into z minus z cube by 3 factorial plus z power 5 by 5 factorial, like that. So if you multiply the z inside, so 1 minus z square divided by 3 factorial plus z power 4 by 5 factorial, like that. So we know that in this expression all z's are in numerator. So there is principal part is absent. So only analytic part. So there is no principal part. So this is removable singularity. So in the expression we can see z in the denominator, but actually it contains only the numerator sets, that is there is absence of principal part, so only analytical part. This is known as a removable singularity. Okay. And next session is about the residue. You know just about the singularity, what you mean by essential singularity, what you mean by pole of order and removable singularity, like that. So next we are going to the residue. So what do you mean by residue? Okay. So residue, if you are find singular points, we know that the singular points, the function is function is, what is that? Function is undefined. Okay, so if you are finding a singular point, if you are considering a domain in which a function which is in a which is undefined at the z is equal to a, that is singular point, and we know that this portion it is undefined, so we can take the integral to remove this part. Okay, so like that, if you are considering a point which is what is this, undefined, so uh, we can find the area by or take integral by removing this part, so that is known as residue. So residue of a function at the z is equal to a, that is we have removed the singular point. Okay, so how to find this residue? If you are considering an essential singularity, essential singularity means the principal part contains infinite number of terms. If you are considering an essential singularity, so the function is f of z is equal to e raised to 1 by z, that is 1 plus 1 by 2 factorial 1 by z square, 1 by z plus, you know that e raised to x is equal to x power n by n factorial. Okay, so 1 plus 1 by z plus 1 by 2 factorial 1 by z square plus etc. So if you all know that the sets, all sets are in denominator part, so it is a essential uh, principal part, that is essential singularity is that. So principal part contains infinite number of terms. So to find an essential singularity, the residue of a function become, that's equal to the function z is equal to 0 is the singular point. Know that, because e raised to 1 by 0, that is e raised to infinity is equal to infinity, so z is equal to 0 is the singular point. So coefficient of 1 by z minus 0 will give you the residue. Okay, that is, you know that in this expression 1 by z coefficient, that is 1, so residue is 1. So if you are considering an essential singular point, the residue of a function at z is equal to a will become the coefficient of 1 by z minus a. So you have to do this problem. What is the method? That coefficient of 1 by z minus a, if this is an essential singularity. So if you are considering a function that is cos z square into 1 by cos z, so that is z square into cos z, that's equal to 1 minus 1 by 2 factorial 1 by z square plus 1 by 4 factorial 1 by z power 4 minus 1 by 6 factorial 1 by z power 6, like that. So if you are multiplying with this, so z square minus 1 by 2 factorial plus 1 by 4 factorial z square plus minus 1 by 6 factorial 1 by z power 4, like that. So if you know that the singular point z is equal to 0, it is a singular point, that is cos of 1 by 0, that is cos infinity. So z is equal to 0 is a singular point. So to find the singular point, this is analytic part, here it is 1 by z square. So this is analytic part, this is principal part. So to find the function residue, for that, this is analytic part, this is This is analytical part, this is principal part. To find the residue at z is equal to 0, you have to find the coefficient of 1 by z minus a. So here 1 by z term is absent. So the coefficient of 1 by z minus a is 0. So the residue of f of z is equal to 0 is equal to 0. Okay, so this is the method. We have to find the residue for an essential singularity. You have to remember this residue of a function at z is equal to s coefficient of 1 by z minus a. Okay, this is the method. Okay, and you have to remember these three expressions, that is e raised to x is x raised to n divided by n factorial, and sine theta is equal to theta minus theta cube by 3 factorial plus theta raised to 5 by 5 factorial, like that. And cos theta is equal to 1 minus 1 by 2 factorial x square by 2 factorial plus x power 4 by 4 factorial, like that. Okay, so you have to remember these type of equations. From that you can find the essential singularity and find the coefficient of 1 by z minus a. Okay, so